Okay, so in our last video, we were talking about good sampling methods. There are 3 basic sampling methods, simple random samples, that we are supposed to know for AP Stats. The first one is hat method. It's the easiest. It's the quickest to describe and the easiest to describe. But as I was saying at the end of the last video, it's not very practical. Most statisticians aren't keeping a top hat in their office and writing thousands of labels on identical slips of paper to draw them out. What they're really doing is simulating hat method. They're simulating hat method. Remember, we learned about simulations last time. A simulation is essentially when we pretend to do something, or we simulate doing something. So we're simulating hat method with our calculator. So this is a simulation of hat method, but we're using our calculator. So in practice, most people use random numbers generated by technology. So for us, that's going to be our calculator. Now in our class, we commonly have 2 calculators that are used. You can use the newer CE Plus or Plus CE, or you can use the older version. So TI-84 Plus. Look how dirty that screen is. How embarrassing, teacher. Or your TI-84 Plus CE. Now they're slightly different. So depending on what calculator you use, you may want to click forward or turn your listening speed on double time while I'm going through the commands that don't apply to you. So if you're using a TI-84, these are your computer commands. So in order to generate a sample, let's say that we have, I don't know, let's go with 50, N is 50, and we want a sample of, I just said N is 50 and wrote down 500. Our population has 500 things in it, and we want a sample of size 15. So how would we use our calculator to select 15 people or individuals from our population? So first of all, we would have to label each member of our population with a number. We would start at 1 and we would go to 500. So if these were students, I would number these students from 1 to 500. So I would match their name with a number. And then I would use my calculator to generate the sample. So for the older TI, we go to Math. So it's the third one down here. You arrow over to Probability. And you choose Random Int No Repeat. So this is option 8, and it's right here on your paper. This is option 8. Now the reason that we have to do no repeats is because if we're talking about students, we can't have 2 of the same student in our sample. A student can only be 1 person in our sample. We can't have any duplicates. So we have to make sure that we use the no repeat option. Our sample has to be distinct, which means we can't have any duplicates, any people twice. So then we enter in our lower bound. So our lower bound is the student that was numbered 1. We use the comma, which is above the 7, and we enter our upper bound. That's student 500. Then we end our comma, and we hit enter. Now if it's an older one, this means it's thinking. It's thinking because what our calculator is doing is randomly ordering all 500 numbers. So if you hit your arrow over button, this list goes on until every number has been listed. So this literally is 500 different integers. So how do we know what our sample is? Well, on the older calculator, you take the first 15 numbers. So I'm going back to the very beginning. So my first person in my sample is person 483, then person 212. That's why you have to have a list of your students and number them. My second is 129, and you keep writing these numbers down until you have 15 people in your sample. There's one issue here with this. If we try to use a sample that is bigger than 999, so if I had 1,000 students instead of 500, my calculator won't do it. It's too many. It won't take 1,000 numbers and randomly order them so that I can select 15. So what we have to do instead is go to Math, Probability, and we have to choose 5 instead. So we may want to write that in. I'm just looking for my red pen. When you have to do it this way, you have to use menu option 5 instead. It's just random integer. Now notice it says you have to hit enter until you have 15, and they must be distinct. So what this means is that you have to ignore repeats. If they're distinct integers, that means you have no duplicates. Ignore repeats. You can have no duplicates. So distinct means no duplicates. So what that would look like instead is I would hit option 5, 1, 1000, enter. So student 8 is the first person in my sample. Enter. Then 750, 705, 229, 548, 864, and I keep hitting enter until I have 15 distinct integers. And if you have to do it this way, you have to explicitly say, I will hit enter until I have 15 distinct integers. So this is the older calculator. If your sample size is less than 1,000, you use this. It'll order your numbers, it'll randomly order them, and you take the first n numbers as your sample. If it's greater than 999, you have to hit enter until you have 15 distinct or n distinct people. Now, if you have the newer calculator, you get lucky. So this guy is same buttons, Math, arrow over to Probability, oopsie, Math, Probability, option 8. And then it's going to pull up a wizard. This is your stats wizard. It's called a wizard because you can easily see what you need to fill in. So for this example we were doing, we would fill in 1 to 500. I need 15 students. Enter, enter, enter. And then this is your sample. This is now only 15 numbers, and these are your 15 students in your sample. Now, one thing that I forgot to mention, and this is the same for both calculators, if you don't immediately hit your arrow button over to see your numbers, it won't let you go back and see them. So like if I arrow up, so I've arrowed on my sample and I try to go over to see the rest of my numbers, like I'm hitting my button, it won't move. If I arrow down and now try to see my numbers, it won't move. So when you're generating these numbers, right after you hit enter, you have to arrow over if you want to see all your numbers. If you don't arrow to the right after you generate the numbers, it locks you out and you can't see them. You would just run it again, but you need to know that they have that little quirk. Sorry. There is not a limitation on sample size for this calculator. And that's because it's not ordering 1,000 numbers in random order. It's literally pulling 15 numbers. The issue with the older calculators is that it takes all of your numbers and just orders them randomly, and you take the first ones that you need. This one does not do that. It just randomly selects 15 and disregards, the algorithm disregards any duplicates for you. So if I enter through this, notice it will work for 1,000. I wonder if it'll work for 10,000. Now I'm interested. So I'm going to change my sample to 10,000 students and I want 15. So the newer calculator does much better at generating your sample. So option 1 is to use your calculator. The commands are different. So if you use the older calculator, you have some limitations. If you use the newer calculator, you're Gucci. You fill in your lower bound, your upper bound, and your sample size. Lastly, before we actually look at one of these examples, how we would describe it, is that you could also use a web-based random number generator. So if I pull over a Google window for us, I could go to random.org and generate my number. It's right over here. So my min would be 1, my max would be 500. But notice on this one, I have to hit generate until I have the amount of people that I want. So this is another one where you would have to hit generate until you have 15 distinct numbers or 15 distinct integers, which means you have to ignore duplicates. And you either have to say, I will hit enter until I have 15 integers and I will ignore duplicates. Or you have to say, I will hit enter until I have 15 distinct integers. So you could do random.org. You could just Google random number generator if you wanted to. I don't want it to fill in for me. And Google has one. So I would do 500 once again, and I just hit generate. The key here is that if you choose to do it this way, it is imperative that you describe, that you're having to hit enter until you get your distinct integers. Or you're taking the first 15 integers listed. On this one, you don't have to state those things because you're showing here that you're entering in the required sample size. So it's very important that you are aware of that. Okay, so next up is describe. We're describing how to select a sample using technology. So the instructions, like the bullet points, are a lot shorter here, but then I give you an example down below. So you got to label the individuals in your population. So you got to give each individual in the population a distinct numerical label from 1 to n. When they say distinct numerical label, they mean an integer. And all an integer is a whole number, 1, 2, 3, 4, 5, 6, 7, 8, 9. So integer indicates no fractions. They say individual because sometimes you're not taking a sample of people. Like you have an example where, or a problem that you do where your sample is gravestones. You would label the gravestones from 1 to 50,000 or however many there are in the problem, and then select your sample. So be aware that sometimes your population is not a human or a living thing. It can be like an actual thing, an inanimate object. Then you randomize, because remember our steps for all of these SRSs, HAT method is an SRS, using your calculator is an SRS, using a website is an SRS. The key elements are label, randomize, select. So we label 1 to n. Randomize is done by technology. And then we select. So if it is the older calculator, you say I would hit enter until I have n distinct numbers and distinct integers. If it is the newer calculator, you just indicate that you're entering the sample size. If you're using a website, you have to say, I am hitting enter until I have n distinct integers. So label, you do that. Randomize, technology does it. Select, it depends on what technology you're using. Okay, one last thing before we actually look at an example of this. So do not attempt to describe a method that you've never actually practiced, because it's going to be obvious that you've never done the method. So if you always use your Chromebook to generate your sample, then on your test you would say, I am using my Chromebook, I'm going to go to the website, blah, 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 or I'm going to Google random number generator. Like, you literally write exactly what you do. It's similar to HAT method. You want to be able to ask somebody else to do this, and they would be able to do it just by following your instructions. So whatever you actually use to generate a sample is what you should describe on my test, on the AP test, on your homework. Don't describe a method that you have never done before. Okay? Okay. So here's our example for technology. A university's financial aid office wants to know how much it can expect students to earn from summer employment. This information will be used to set the level of financial aid. The population contains 975 students who have completed at least 1 year of study but have not yet graduated. So this means that capital N is 975. Capital N is 975. A questionnaire will be sent to 50 of these students. So this is little n. We're going to draw these students from an alphabetized list. Explain clearly how you would use technology to choose a simple random sample of 50 students from this population. So, step number 1, label. Label each student on the alphabetized list because they're specifically telling you that it's alphabetized. Label each student on the alphabetized list with a distinct integer, meaning you're going to have no repeats, from 1 to 975. Where am I getting 975 from? That's how many people are in your population. 1 will be assigned to the first name on the list, and 975 will be assigned to the last name on the list. So I'm just trying to be as clear as possible how you would do this. You would have a list of students in alphabetical order, and you would literally write on the paper 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down to 975. When I say write, I mean you're probably going to use Excel and have Excel number the students 1 to 975. If you're a real statistician, you're using computers to do almost all of this. I will use my calculator, so notice I'm just flat out saying I will use my calculator to generate a list of 50 distinct integers. And then I'm going to give my commands. So if you have the older calculator, these are your commands. And notice right here, I have to say I will use the first 50 integers. Because if I have this older calculator, it gives me a list. It'll give me a list of all 975 students. Like if I go in and do this right now, change this to 975 and hit enter, it's going to think for quite a while. Oh, I have the wrong command. Sorry about that. It's going to think for a while, and I know it's thinking because of this bar right here. And the reason it's taking is so long is because it's taking 975 integers and randomly ordering them. So when it's finally done, I have to arrow over until I have 50. I take the first 50 integers that the calculator gives me. I have to write that down. I will use the first 50 integers. If you have the older, just kidding, the newer calculator, all you have to write are these commands. Math, prob, 8. Your lower is 1, your upper is 975, your n is 50. This tells your grader that you know your calculator will give you 50 integers. You don't have to do anything special. Then lastly, you have to say the students that match the 50 integers generated will be my sample. You have to be very specific. So the students that match those numbers generated will be your sample. If you're going to describe a website, you would say, I will go to random.org and generate a list of 50 distinct integers. I will enter 1 for my lower bound, 975 for my upper bound, and I will hit enter until I have 50 distinct integers. So you have to explicitly say, I will hit enter until I have 50 distinct integers. So hopefully you are taking away from this that you have to be as explicit as possible, like so explicit. So we have 2 good methods so far. We have a simple random sample. Just kidding. We have 2 good methods. They're both simple random samples. Simple randoms are the easiest ones. There are 3 of them. We have done 2. Hat method, easiest, not practical. We're not carrying around a bunch of top hats. The most often used is technology. Most statisticians are using computer programs, but we use our calculator. We got to be as explicit as possible in describing how we get our sample. And that is it for part 2. Now, the third way that we can do this, family. It is quite an adventure, which is why you're not doing this at home. So I have specifically calendared for this class so that I can be with you when I teach you the third simple random sample. 3 simple random sample methods, hat method, technology, and the last one's called random digits. So the first 2 are what I would always choose, and I would never do random digits unless I was specifically asked to, and sometimes you are. So the last one is a little bit more challenging. That's what we're doing in class next time. I will probably begin class with a couple of quick problems for you to actually generate a sample so that you truly know what we're doing here and we're not just speaking hypothetically about how we would do these things. So the plan is for now that I'm not going to attach any more work to this. We'll practice this in class. Okay, that's it. Love you guys.